Alright guys, so what we're going to be doing today is we're going to be doing, continuing what we were doing yesterday, and throw in a little bit of a twist. So, first thing we're going to do is I'm going to re-explain what each thing is when we're talking about conditional statements. So, I'm going to first write I'm going to say if it is a cow, then it will move. Okay, so the first thing is if it is a cow, it will move, and then it will moo. There's two parts to this. The thing that follows the if is always the hypothesis. The thing that follows the then is the conclusion. So, we have the hypothesis and we have the conclusion. Now, when we have the hypothesis and we have the conclusion, there are different types of negations that we have to do in order to really understand what this is. So, we're going to take this statement as true, that if it is cow, it will move. We're going to take that statement as true. Alright, so now, the first thing you guys know is the converse. Okay, so what the converse does, guys, is it takes the hypothesis and it takes the conclusion and it flips them around. Now we keep the if and then where they're at, but we flip up the statements. So it says if it will moo, then it is a cow. Okay, so stuff like this. Hold on 1 second. Stuff like this, the converse is usually false. The reason why it's false is because look at this. Alright? If it will moo, then it is a cow. We usually have to look at this and be like, okay, so does that make sense? If it will moo, then it is a cow. Well, I mean, technically I can go moo, that does not make me a cow. Alright? So this statement is incorrect, and how we say this statement is incorrect. We say, okay, so we think this is false. Why do we think this is false? Well, think of one thing that can go moo that's not a cow, because what happens with the conditional statement is the if has to be then followed by the then. That means if this is true, this also has to be true. Well, in this case, if this is true, if it will moo, let's say I go moo, then it was a cow. Well, obviously I'm not a cow, so false, humans can go moo. And this is what we were talking about last time with counterexamples. This is on the front sheet. This is a counterexample to the statement. I just proved this statement wrong right here by providing something that also goes moo, but that is not a cow. So the hypothesis is not followed by the conclusion, because if this is true, this does not mean that this is true. The inverse. Right? The inverse is taking this original statement and making it negative, meaning instead of having it say if it is a cow, we say if it isn't a cow. Then it will not moo. Okay? So most of the time, the inverse and the converse are usually false. It's not all the time, but most of the time it is. We're going to get into later today what it means to be if it is true. So if it is a cow, then it will not moo. If it isn't a cow, then it will. Okay, so once again, false. Well, let's think of something, once again, that is not a cow, but will moo. Okay, so this is once again trying to think of a logical statement of why this is false. Well, we can actually go back to what our converse said, alright, because it says if it will moo, then it is a cow. Well, if it isn't a cow, then it will not moo. Well, once again, if I moo, this proves the statement wrong. I'm not a cow, but I do moo. So guess what? Humans can go moo. Okay? We can do the same thing. Finally, contrapositive. It does what both the converse and inverse does. The converse switches it around. The inverse makes it negative. So that's all we're going to do with the contrapositive is switch and make negative. So we're going to switch it, meaning we're going to write this first, but we're going to make it negative. So we're going to say if it does not moo, then it is not a cow. Okay? So if it does not moo, then it is not a cow. Now, this statement is actually true because if we go by this, if it's a cow, then it will moo. It means if it doesn't moo, well, we've already made the statement that the cows moo. So if it can't moo, then obviously it can't be a cow because cows moo. Alright? Doesn't matter if what it is, alright? It's a fox, whatever it is. This statement is actually true. Most contrapositives are true. Most of these two are false. So what we're going to have to start doing is creating a false statement and explaining why it's false, giving me a counterexample of why this is wrong. And do one more. Okay. If it is a circle, then it will have no sides. Okay, so if it is a circle, then it will have no sides. Now, we gotta do the converse. The converse, once again, is where we flip it around. So instead of saying if it is a circle, then it will have no sides, we reverse it to say if it has no sides, then it is a circle. Okay, so we can see this once again that why is this false? If it has no sides, then it is a circle. Well, I can tell you this is false, because let's think of another shape that has no sides. Well, an oval. An oval is in a circle, but it has no sides. So this proves the statement wrong. If it has no sides, well, let's say oval, then it's a circle. Well, oval is not a circle, so this hypothesis is not followed by this conclusion. This makes no sense. Then we got the inverse. Alright, the inverse is the negation of this. Now, we see no negative word in here, but we see one here. So this is what's going to happen. We have to add a negative word to the hypothesis, but we have to make this a positive. Alright, we cannot have this as a no sides. So we have to do something like this. If it is not a circle, then it will have sides. Well, if it is not a circle, then it will have sides. Well, that's not necessarily true because oval, once again, is a no-sided figure, but it's not a circle. So oval is not a circle, but it doesn't have sides. So this statement, once again, is false because we just proved a counterexample, oval. Oval makes it so that you have something that's not a circle, but it doesn't have sides, so it proves the statement wrong. Now remember, counterexamples you don't have to have much of them. You only need one to prove a statement wrong. Finally, contrapositive. Alright, so we flip, and then we negate it. Okay, so that means that we say if it has sides, then it is not a circle. Well, that is actually a true statement, because if it has sides, it can't be a circle, because there is no sided figure that creates a circle. So, if it has sides and is not a circle, is a true statement. Now, sometimes we get things that are called biconditional statements. That means that everything is true, that when you reverse stuff, when you make negations of stuff, it still holds true. Now, let's think of one. Let's say if it is water, then it has the chemical makeup of H2O. As you guys know, H2O is water, so if it is water, then it has the chemical makeup of H2O. Well, let's do the converse. Let me show you something. Remember, converse means we just take this and flip it. If it has the chemical makeup of H2O, then it is water. Well, there's only one thing that has the chemical makeup of H2O, and that is water. So if it has chemical makeup of H2O, then it's water. This is one of the instances where the converse is actually true. Alright? The inverse. Remember, we negate that thing. If it isn't water, then it doesn't have a chemical makeup of H2O. Well, that's a true statement. If it isn't water, it can't have the makeup of H2O, because H2O is the only one that has the chemical makeup of a 2 hydrogen and 1 oxygen. So, that is also a true statement. Alright? I could do the contrapositive too, but I'm not going to, because I'm just trying to show you that this is what happens when you have a biconditional statement. Now, when you have a biconditional statement, you have to create another way of saying this. Okay, so instead of saying if it is a water, then it is then it has a chemical makeup of H2O. We say something like this: biconditional statement. Right? It is water. Right? So we took out the if and we just put it is water. Right? Here comes the if. If and only if. This is what makes it biconditional, is if and only if, right? It is water if and only if. And then we're going to take the conclusion. It has the chemical makeup of H2O. If and only if it has the chemical makeup of H2O. It is water if and only if it has the chemical makeup of H2O. So that's the biconditional statement. And we can only do the biconditional statement if both the converse and inverse are also true. If these were false statements, then we would have just a normal conditional statement, and we couldn't write this biconditional statement. Okay. Let's do another one so I can show you again. if it has four sides, then it is a, if it has only, I put the stipend only four sides, then it is a quadrilateral. Okay. So what this means, a quadrilateral means, all it means is something with four sides. These are your rectangles, your parallelograms, your squares, so on and so forth. If it has four sides and only four sides, then it actually is a quadrilateral. So that's what a quadrilateral is. So first, let's make the start conditional statement. Let's make the converse. If it is a quadrilateral, then it has only four sides. Well, this is true. If it is quadrilateral, it only can have four sides because quadrilateral just means four-sided figure. So this statement is true. Inverse. Okay, so let's look at this. If it isn't, if it doesn't, have only four sides, then it isn't a quadrilateral. But once again, if it doesn't have four sides, then it isn't a quadrilateral. That's a good definition, because if it doesn't have four sides, it could have 3, 8, 0, doesn't matter. Without just having four sides, it can't be a quadrilateral, so that is also a true statement. So now what we look at is the biconditional. So we have to go back up here, take the if off, take the then off, and instead of combining these two together, in the middle we put the if and only if statement. So we say it has only four sides if and only if it is a quadrilateral. So that's the concept. Okay, so that's what biconditional means. It's a biconditional statement. So you guys are going to be practicing this stuff today. There's biconditional statements, all your converse and all your counterexamples and stuff like that.